everyone, Mr. Bainey here. Thank you for watching my videos. This lesson is 3.2, Understanding Relations and Functions. The essential question is, how do you represent relations and functions? So in the Explore activity that I'll go through with you, you'll see the definition of relation. It's a set of ordered pairs. So we have these x's and y's. X's, remember, make up the domain or all the inputs, and then the y's make up the range or all the outputs. Relation, think about relationships. X is related to y in some way. So if you look at this first relation, we have 4 ordered pairs, and the domain is these inputs or these x values, right? 1, 2, 3, and 4. And then the range, there's actually a mistake here. We got 4, 8, 12, and 16. So this first range value should be a 4. So 4, 8, 12, and 16. So let's look at the Explore activity here, parts A, B, C, D, E, and F. Part A gives us the relation. So our relation has the ordered pairs. Right here we got, looks like 7 of them. So if we were to fill in this table of values for part B, all of my domain values are going to go in the first column. So I got 7, 8, 9, 10, 10, 11, and 12. And then the range values, make sure they're paired up correctly. So 7 is paired up with 41, 8 is paired up with 45, and so on. And this is one of the representations of relationships, or relations. So we have a set of ordered pairs, part A. We have a table of values, part B. And then part C, we are now going to plot these points. So 7, 41, 8, 45, 9, 49, 10, 52, and 10, 53, 11, 55, and 12, 59. So it'll look something like this. So this is our third representation of a relation. In part D, our fourth representation is called a mapping diagram. And it looks like this on the right side. So 7 is paired with 41, 8 is paired with 45, 9 is paired up with 49, 10, 52, and 10, 53, 11, 55, and 12, 59. Okay, so this is a mapping diagram. The arrows are just drawn from the domain values. Remember, domain, or my x values, or my inputs, and the arrows are drawn to the range. So we start with the domain value and go to the range. The domain is everything in my first box there on the left. So 7, 8, 9, 10, 11, and 12. Notice that 10 gets used twice, but I only write it down one time right here. And the range is 41, 45, and so on. Okay. And there you have it. So with these relations, know all the different representations that you can use or that you might see, and then also be able to pull out the domain and range out of any of them. Now that we know what a relation is, we'll be able to determine, is the relation a function or not. So here's a formal definition, and it's a little bit confusing, but we'll work with some relations and figure out how they're a function or not. So a function is a type of relation in which there is only one output value for each input value. So each input, if I just read it the other way, each input value has only one output value. Okay, so let's take a look at an example. For this part B, page 117, we have three different representations of this relation, and it represents the amount of gas in gallons and the distance traveled in miles using that amount of gas. So here I have the domain, and in blue is the range. For the mapping, there's my domain, there's my range. Now for the graph, it's a little bit tougher, but my domain is these values that are down here with the gas. My range is these values over here for the distance. So you have to kind of look a little bit deeper for those. The domain values, let's write those down, is 10, 16, 17, and 20. It represents gallons of gas. My range, 150, 240, and 300. And it represents the miles, or the distance in miles. Okay. I'm not going to be filling out the next 4 lines because it's a matter of just knowing what's paired together. So if the input is 10, the output is 150, for example. So let's take a look at if this is a function or not. So remember that each input value has only one output value. So let's take a look at this. I'm going to look at the mapping diagram. You can certainly look at any of the other representations, but you look at 10. How many output values does 10 have? Well, I just look at the arrows. So it has only one right there. 16 has only one. It's that one. 17 has only one. And 20 also has just one. So this is a function. Here we go. This relation is a function. Each domain value is paired with one range value. Okay. Go ahead and try the your turn before seeing the solution. I'll ask that you please think about the same things that we did on the previous example. The domain is 2, 3, 4, and 5. The range is 4, 6, 7, 9. So now think about, is this a function or not? So let's look at the table of values this time, actually. So I'm going to look at all my inputs. So 2, I don't see 2 anywhere else, so 2 only has one output. The 3, I don't see 3 anywhere else, so 3 only has one output. The 4, same thing, I only see that it has one output. And 5 only has the output of 9. So this is a function. This relation is a function because each input has just one output. Okay. Also go ahead and try number 4 if you haven't already. The domain is my inputs are my x values, and my range is my y values. Okay? And we want to determine, is this relation a function or is it not a function? So if I look at, let's go back to the mapping diagram. If I go to 20, my input here, remember we're checking each input, how many outputs does 20 have? It has only one. There's only one arrow from 20. 30, how many outputs? It has one. 35 has one output, and 36 has one output. So this relation is a function. And it is a function for the same exact reason that I put in the previous problem. So I'm not going to rewrite that, but it'll be the explanation that each input has its own output. So both of these your turns are functions. If you would like to look back at our Explorer, the Explorer problem is actually not a function. So that's a good example to look at. On page 119, let's check this. Let's use this vertical line test to determine if this is a function or not. So number 6, we have a bunch of points. So I'm drawing points on this curve. There's actually an infinite amount of points. I can draw even more points in between those, but this is just to give you a sense of the fact that this curve contains an infinite amount of points. So the vertical line test is going to use vertical lines to determine if it's a function or not. So I'm drawing a bunch of vertical lines, and this is a way you can show your work using the vertical line test. I'm going to try to draw them as straight as I can. And think about tons of vertical lines. So I'm going to draw some more vertical lines in here. And the question here is, do any of these vertical lines touch the graph more than one time? So can I pick a vertical line that touches the graph more than once? So I drew maybe too much vertical lines, but you need to think of every single one anyway. So do any of these vertical lines touch the graph more than once? And the answer here is no, it doesn't. It only touches it once or none at all, right? If I start drawing more and more to the left or to the right. So this, because there aren't any vertical lines that touch it more than once, so this is a function. Okay. For number 7, if I start drawing some vertical lines, for example, this one, or this one. Now if I draw this one, or even this one, these don't touch the graph more than once on the right side, but the one that I drew in the middle here, this does touch the graph more than once. It touches it at this point right here and at this point. So for number 7, this is not a function because it touches the graph more than once. And we don't necessarily need to put an explanation here as long as you have that vertical line that sort of messes it up. Think about this. The top point that I marked is the point 0, 4. And then this one down here is 0, -4. Think about what this means. Using the definition, we have an input. The input is 0. And this input gives us an output of 4. And here, this input gives us an output of -4. So this messes up our definition because we have an input that gives us 2 outputs. So that's why this is not a function. And the vertical line test is just I want to say shortcut. It's like a quick way of determining if a graph is a function or not. Okay, and that's going to be it for this lesson. Thank you so much for watching again. Have a good day.